Let's take a look at number 103. We're given the velocity initial and the velocity final and the time, and we want to know how far it moves. Well, in order to find out how far it moves, we've got to find the acceleration. Let me stop there for a second. The reason I know that I need to find the acceleration is because if I look at all of my kinematics equations that have the letter D in them, they all also have the letter A. So in order to find distance, we need to find the acceleration. So we can use this equation here to find the acceleration. I'm going to rearrange it to just solve for A, and let's plug in our numbers and see what happens. 9.7 meters per second squared. Okay, let's write that down. Now let's go back and we can find the distance. I'm going to use this equation right here. I'm going to rearrange it to solve for D, and then I'll plug in my numbers. And we have our distance. Number 106, we are dropping something. Let me stop here for a second. Anytime we're dropping something, our velocity initial is going to be 0. The only time it won't be 0 is if you're throwing something up or throwing something down, but if you're just dropping it, it's always going to start at 0. The final velocity is given. It's a negative number because we're dropping it, so it's falling down, and we always call downwards negative. And the acceleration, this is something that we didn't discuss in class, so I apologize for assigning this question for homework. The acceleration on Earth is always negative 9.8 meters per second squared. That is the value of the acceleration due to gravity. And it's a negative number because it's always pointing downwards. It's always accelerating objects downwards. So we want to find the distance, and we also want to find the time. So considering what we know, we can use the VF squared formula, rearrange it, and solve for D. And we can put that in the bank. Now once we have the distance, well actually we don't even need the distance to find the time. We can use this formula here to rearrange it and solve for time and plug in all of our numbers. Alright. In question 109, we are given the final velocity. We can assume that the initial velocity is 0 because it's a gun, so it's starting from rest. The bullet, or in this case the satellite, is starting from rest. Now what I just did was I converted 35 kilometers per second into meters per second, and then we got to convert our distance, which is in centimeters, into meters. Remember that in this class we always use meters and seconds, so if you have anything other than that, then you gotta convert. Okay, so we're solving for acceleration here. That means we can use the VF squared formula. Let's rearrange it to solve for variable A, acceleration, and then let's plug in our numbers. Now, we have acceleration, so we now need to find the time. So we can use this one here, rearrange and solve for T. Let's plug in our numbers, and we can figure out how long it takes. It's going to be a very small number because this is a gun. That's like asking how long is the bullet in the barrel of a rifle. So it's going to be a very, very small amount of time. So please, please, please don't forget to convert your units into meters or seconds or whatever it happens to be. Okay. Let's take a look at number 110. This is a sled. We're given the initial velocity. You're starting from rest, and then you get up and speed really, really fast. They give us the time it takes to speed up and also the time it takes to slow down. So the acceleration for speeding up, we can use this equation, rearrange for A, except when we plug in our T, it's just going to be the speeding up time. And now we have our acceleration for speeding up. The question also asks to compare it to the magnitude of velocity. The magnitude of gravity. Gravity is 9.8, so this is 247. So to figure out how it compares, we can just divide 247 by 9.8, and it's 25. 25 times the speed of gravity. Another way of saying that is 25 Gs. So when you talk about G-force or experiencing Gs, we're talking about how many times the speed of gravity it is. How many times the acceleration of gravity, it is. So this particular sled is 25 times the magnitude of gravity, or 25 Gs. If we want the acceleration for stopping, we just need to plug in the time for stopping. So it's a very similar equation. We're just using the time to stop instead of the time to start. We can divide by 9.8 to figure out how many times the value of gravity it is. It's 21 times, so we can say 21 Gs. How about 112? We have a truck that's accelerating starting from rest, so let's plug in our information for the truck. We also have a car. The car is moving at constant velocity. So, what are we going to do here? We want to figure out when they meet each other. So, when they meet each other is when they have the same value of d, when they have the exact same distance. Also the same value of t. The moment that they are at the same exact place is when they have gone the same distance and the same time. You could think about it as them being in the same place in space-time, if you're feeling existentialist. Anyway, so check it out. We got our our equation for the displacement of the truck and the car. Turns out we can sort of simplify here. The truck doesn't have any initial velocity, so we can cross out that first term. The car doesn't have any acceleration, so we can cross out that second term, because they both go to 0. Now, they have the same d, the same value of displacement for this particular question, because it's asking when they meet each other. So we can set these two things equal to each other. We can say 1/2 at squared equals vt. We can simplify the t's here by dividing both sides. And let's rearrange it to solve for t. T equals 2v over a. When we plug in our values, we get 12 seconds. Now, we know the time, and we need to know the distance. So you can plug into either one to get the distance. I circled the car because that's easier. There's no acceleration, so it'll be easier to find the distance. So I'm going to go on to the next page and solve for the distance using the car. You could use the truck, you will get the same exact answer, but I'm going to use the car because it's easier. We have our velocity and our time, so we can simply multiply them together to find the distance. Let's take a look at 113. We have the acceleration that the human body can withstand. We're coming to rest, so that's a VF of 0. Our VI is given, but it's not in the right units. We got to put it into meters, and we got to put it into seconds. So let's stop there for a second. Take a look at what I did. To go from kilometers to meters, you need to multiply by 100. To go from hours to seconds, you need to divide by 3600, because there are 3600 seconds in 1 hour. I like to do these conversions in one fell swoop, all one calculation. And now we have our velocity in meters per second, which is 30.56 about. I'm keeping a couple extra digits here just for the sake of precision. So, anyway, what are we doing here? We need to find the distance. Okay, so let's use this formula. This has everything that we need. We can rearrange it to solve for d, and then let's plug in our numbers and see what happens. Okay, cool. So we have 1.6 meters. And, oh, that's the answer. Cool. Alright guys, we're done. I hope this was helpful.